I think we're live. Hello, everyone. Welcome to Leonard, the Vinci's innovation and foresight platform. Among our activities, we have two startups programs, Seed, to help new startups structure their business plan, and Catalyst. This program was launched in January and is designed to foster and accelerate partnerships between Vinci and startups or scale-ups in their commercial development phase. Today, the 7th of our 11 daily online presentation of startups from our Catalyst program and their exchanges with operational business units from Vinci. I would like to begin by thanking our panelists today and the audience for your virtual presence. Today, you'll hear Converge CEO Raphael Scheps. He will exchange with Bruno Paul Dauphin from the Momentum Project and Low Carbon Concrete at Vinci Construction. We'll first hear the presentation of Converge and its value proposition. Then Bruno will introduce himself. After that, we'll begin our exchanges. You can also ask your questions in the chat, and I will be your voice at the end of the exchange. And during the presentation, you can click on the slides to see them in a bigger window. Raphael, you have the floor.
Great. Thank you so much, Louis, and delighted to be here to talk about our collaboration with the Vinci Group. So I'm just going to try and share my screen. Cool. Can everybody see my screen?
Perfect.
Awesome. So I'm going to give you guys a bit of an introduction into Converge. So first of all, hi, everyone. I'm Raphael Scheps, the co-founder and CEO at Converge. And Converge is all about digitizing the physical world on construction sites using sensors. So as many of you, looks like, there we go. As many of you will probably be aware already, the construction industry has a huge digitization and efficiency problem. McKinsey reports a $1.6 trillion labor productivity gap, and it's also one of the largest and most polluting industries in the world. If you look at cement, for example, it accounts for 7% of global carbon emissions. So there's a huge problem in the construction industry when it comes to efficiency and sustainability. And we believe that the best way of solving that problem is through data from sensors and data on the construction site. McKinsey's done a really great job at breaking down the problem into 7 areas that contribute to the productivity gap. And it's the design and engineering, the supply chain and procurement, the execution and orchestration of these site activities, and then the lack of technology that we think can be disrupted through better data on projects. There are other areas like training and education, the contractual framework, or regulatory frameworks that are really for governments to drive. And actually, what's been pretty incredible at Converge is that we've seen this transition in the industry over the last 18 to 24 months, and Vinci's been a great kind of big part of that, where large construction groups have realized the importance of data and technology and are starting to actively invest in finding better ways to drive project data. And as a result, make more efficient decisions on construction sites. So we believe Converge is best placed to bridge that productivity gap for one simple reason. Our entire model is based on driving efficiencies on the construction site through sensors and AI. So we collect physical data from sensors that may be placed on assets, on materials, on tools, in the environment itself. And then we fuse that data with what we call construction data. So really at the core of Converge's technology layer, there's what we call construction DNA. And construction DNA takes that physical data from those sensors and links it into the BIM model, so the 3D model of the project, links it into program data, links it into economic data or sustainability data that might come from an ERP system. And when you start to fuse that physical data and that construction data, that's when you're able to really start orchestrating site activities in a much more efficient and sustainable way. And that core piece of technology permeates every piece or product that we deliver to market. And as I mentioned earlier, the vision really is to have sensors on everything. Sensors in concrete, which is where we started and what I'll do a bit of a deeper dive on in a second, but also sensors to monitor structural and environmental factors on the site, to start looking at the performance of assets, sensors to look at the logistics and the efficiency of the logistics process on the construction site. For example, on the crane, which is one of the major bottlenecks to the delivery of the site, but also in the off-site construction process. And all that data then feeds into this data engine that we call construction DNA. Now, product number one that we shipped to market a few years ago and that we've now started scaling quite rapidly is called Concrete DNA. And concrete DNA is all about optimizing the concreting cycle on a site. So concrete is the second most widely used material in the world, and as I mentioned earlier, cement, one of its constituents, accounts for 7% of global carbon emissions. And it sits on the critical path of the majority of projects. If you can't deliver the next step of a construction site, typically it's because the concrete's not quite ready and you've got to wait for it to cure. So what I'm going to do is I'm going to try and jump into a video which introduces concrete DNA as a product. Hopefully this will work on this webinar. And let me know if it doesn't.
At Converge, we've cracked the concrete genome. So we created Concrete DNA, your platform for analysis, prediction, and collaboration on your concrete pours. It's powered by this guy, Converge Signal. It's small and powerful. It sends real-time concrete strength data to concrete DNA. It means you're going to optimize costs, strike faster, guarantee safety, and avoid delays. All of this whilst reducing your carbon footprint. It's good to be the good guy. And because concrete DNA is in the cloud, teamwork has never been easier. Anyone can access the data from anywhere at any time. Okay, but how simple is it to set up? That simple. And it's not just easy, it works. Concrete DNA has already helped build structures up to 30% faster, which is why some of the leading contractors around the world have been working with us and reaping the benefits. But concrete is just the foundation. Let's think bigger. We're building a network of sensors that form construction DNA, the future of the job site. Tracking prefabricated assets, scheduling crane lifts, monitoring structural and environmental factors, all to optimize efficiency and sustainability. Construction DNA links data from sensors with BIM models, construction programs, and cost data to create a real-time digital twin of the job site. Join us to build the future, a world of interconnected sensors and an intelligent data platform where they all converge.
Cool. So that was a quick introduction to concrete DNA and also where we're headed as a company. And I'll do a bit of a deeper dive now to talk about the value proposition and how concrete DNA delivers value on construction sites and makes them more efficient. Cool. So you can see the Converge Signal on the right of the screen. So Converge Signal is one of the hardware offerings that we provide as part of concrete DNA. And it's a sensor that's fully embedded. So as you saw in that video, it's about 4 centimeters across. It's quite small. Gets attached to the reinforcement in the rebar in your concrete, and then helps you monitor that concrete in real time, providing a compressive strength curve, which is really what drives the program for construction sites. There's then a mobile app that construction operatives, site engineers, principal engineers, and other stakeholders on the site are able to use to start tracking the performance of concrete in real time. And what they get to see is the temperature of that concrete, the relative humidity of that concrete, but most importantly, its strength. And strength drives the productivity of applications like post-tensioning, jumping core, tunnel segments, etc., which is where the majority of the kind of operational efficiency improvements come from. I think one of the coolest things that we've done as part of concrete DNA is we've now gathered data from probably close to 15,000 sensors. There's well over 10 to 15 million data points on the performance of concrete in the field. And we've actually been able to now predict the behavior of concrete given the weather forecast. So this is the world's first use of AI to build a predictive engine that can actually tell you up to 5 days ahead of time with over 95% confidence levels when your concrete's going to hit strength, and as a result, when you're going to need resources to start taking action on that factor. The other thing we've done is connect into BIM. So as we saw in that video, and as I mentioned earlier, construction DNA's core technology layer helps you start to understand how your kind of progress is going from a sensor data perspective. So we start to link the physical data to the construction data. And I'm quickly going to do an introduction or a demo to the product itself. So this is Concrete DNA Live, and you can see sensors on your screen here. You're able to click on them and actually start looking at data coming in for those sensors, the real-time strength, the temperature, and you can actually start to navigate across different sensors and click on a detailed view that allows you to actually start understanding how that specific concrete element is performing. And here you've got your predictions that are showing up in terms of when different strength milestones are going to be hit for that particular concrete pour. You're then able to actually move into the BIM viewer. So this is where we start linking physical sensor data into BIM, get an appreciation of progress in real time in a very visual way, and actually start to time step through progress on your site as well. Finally, we aggregate that data, so we're able to actually start understanding trends on your construction sites and how concrete drives the efficiencies and operational improvements on the project. So what does that actually mean in terms of value, and why do we care? Well, some of the largest contractors in the world have used concrete DNA, Vinci, of course, but also many tier 1 contractors that you'll probably recognize on this slide. The technology has been used on over 200 to 250 projects. Now, I'm briefly going to talk about a few of the use cases that we've had within the Vinci group for our technology. So actually, the very first use of concrete DNA within Vinci was at the Victoria Station upgrade. For those of you who live in London, you'll recognize Victoria Station as one of the biggest metro or tube stations. Concrete DNA was used in the tunnel segments to start optimizing the speed at which the tunnel segments were built. So that was a 24/7 job, and they were striking those tunnel segments after about 12 hours and then moving on to the next segment. And with Converge, we were able to demonstrate that they could move from a 12-hour cycle to a 7-hour cycle, which compounded over that project is huge. We've also worked with Bachy Solitange in the piling sector, where we've put our sensors and concrete DNA and used concrete DNA in the piling environment to actually act as a quality assurance record for the temperature profile of the pile, and also the strength level of the pile, reducing a lot of admin around cube taking. Highways has been another sector, in particular concrete highways, where Seymour White, one of Vinci's subsidiary in Australia, made use of the concrete DNA platform. And it was all around optimizing activities like saw cutting and trafficking on the road itself. So this is one of the major highway projects in Australia at the moment. And then finally, rail, and I'll spend a bit more time talking about this specific use case because I think it's quite a compelling case study. Concrete DNA was used to essentially help Taylor Woodrow, who was a UK subsidiary of the Vinci Group, build essentially underpin a rail structure that had about 13 archways. And they had to build these concrete elements underneath the existing structure, and strength was critical to the program. So to explain the use case, you had about 13 archways, which you can see on the screen here. So 13 piers supporting the railway, and a new structure was going to be built on top. Underneath each pier, you had about 8 underpins that needed to be built in a sequence. And concrete DNA helped optimize that sequence, which was strength dependent. So every time a new bay had to be built, it had to be excavated, the concrete had to be poured, and then the site operatives had to wait until that concrete reached a strength of 2 megapascals before they were able to grout. And that was milestone number 1 that we were optimizing. We were then having to wait for the underpinning to complete and for the concrete to reach a strength of 15 MPa before you could excavate the next bay. And so that whole cycle was completely concrete dependent. And as you can see on the slides, we were able to demonstrate and move from a 2-day cycle to a 1-day cycle. So Taylor Woodrow worked in additional shifts and was able to actually create a 50% saving on program, which on that month-long construction schedule was able to actually save about 2 weeks, which is huge, both in regards to the operation of the structure, but also in regards to just delivering on time and optimizing efficiencies on the sites. And so, as I mentioned, the technology is applicable to many different sectors, from bridges to infrastructure to high-rise or prefabrication. So that's really just the beginning. And as the video touched on earlier, this all fits into a much bigger future that we're trying to create, where the job site is smart and sensors are driving and creating data from pretty much anything. And actually, we've got 3 new products on the way: GeoDNA, Offsite DNA, and Crane DNA. And each of these uses a component of physical sensing on the site, coupled with construction data to help optimize the delivery of a particular problem. And all of them, though, fit into construction DNA, which is the data platform. So GeoDNA is all about structural and geotechnical monitoring. So we're actually extending the Converge Signal, which is the hardware sensor that you saw earlier, to start monitoring parameters like tilt, movement, vibration, load, and strain. And that's actually being used in structures to start understanding their performance, both during construction to optimize temporary works and construction sequencing, but also after construction. And so today, the sensor, which is embedded, lasts between 2 to 5 years. We hope to be able to get that to a decade, and if not multiple decades one day, so we're able to actually have the sensor last as long as the design life of that particular structure. Offsite DNA is all around prefabrication and the optimization of the logistics process for offsite construction. So we're actually starting to use sensor data to optimize the delivery and logistics routes for modular construction, and also looking at sustainability, so actually understanding the carbon impact of those delivery routes, so you can minimize the embodied carbon in that construction process. And finally, crane DNA looks at the on-site logistics, so looking at sensors from the crane to actually optimize crane sequencing, lift scheduling, crane cycles, etc., and all the activities that flow from the crane. And the vision is to get an integrated view where offsite DNA, crane DNA, concrete DNA, and GeoDNA all work together, feeding into construction DNA and providing a holistic view of the whole construction sites. And it doesn't really stop there. The more data feeds you get, the more value you're going to be able to drive. We demonstrated, between 30 and 40% operational savings when it comes to concrete DNA. And I think when you start to add data streams across multiple processes on the construction site, that's when you start to benefit from the synergies. And that's when things get really, really powerful and lead into this vision for construction DNA, the digital twin or physical intelligence layer that connects all those data feeds and provide the construction site with a global view of what's really going on, and the construction groups with a benchmark of performance across the wider portfolio of sites. And that's really an introduction to Converge.
Thank you, Raphael. It was really a complete presentation. Bruno, good evening, and thank you for joining. Can you describe your activity on low carbon concrete and, of course, the Momentum project, on which we'll get back also?
Yes, sure. Hi, everyone. I'm Bruno Paul Dauphin, working for Vinci Construction. And as Louis said, I have currently 2 hats. One for the low carbon concrete project, leading this project for Vinci Construction, and the other one here in Léonard program to be part of the entrepreneurship program with the Momentum project. And I can give you a few description of these 2 activities, because both of them, as you can see with the great presentation from Raphael, might have opportunity and has already we have already used the service of Converge specifically for a project. Low carbon concrete, just a few introduction, because most of people, they know that there is an emergency to do something on the carbon footprint, in particular for concrete, and there are alternatives to the classical concrete, where we can substitute most of the clinker part of this concrete with lower carbon footprint materials. So it means that there is opportunity to get a concrete and a construction much more sustainable than the classical one. So that's one of the projects, and we have a lot of opportunity for that. The other one is the Momentum project, and Momentum project, it's at the end, it's how to support the concrete, and in particular for the construction sites, how to help them manage their concrete from the beginning to the end. It means that by having a lot of interview, much more than 200, I think now, we identify that they have an issue in the choice of the concrete, and in particular the low carbon concrete. So we have an issue, a pain in the choice of this, lack of visibility. There is an issue in managing the concrete on site and in particular to the traceability of the concrete, and it's really paper driven. And so the idea is really to put a platform, to develop a platform which will help and facilitate the work on site. And what is the link with Converge? Currently, nothing at this stage, but this concrete ADN, which gives a full traceability of the concrete along the construction sites, and in particular increase the productivity, is very critical for us. Digital is to make it simple, but there is a lot of transformation associated to this. And we think that having these sensors in the concrete gives information on time, real time, about the real strength, and so you can increase the productivity. The low carbon concrete, and I told you that it's not using just clinker, so it's using materials like slag, like fly ashes, and these materials, they have not the same compressive strength. So the early age, what we call the early age for the concrete, is longer. So it means that knowing more about this compressive strength directly from the sensors can help the adoption of low carbon concrete. And that's the two opportunities where I was really pleased to work with Raphael and his team recently in Poland to test these capabilities, and from my understanding, the results were interesting.
Bruno, can you tell us a bit more on the project in Poland? What we are constructing, and what's the project?
In fact, it was so when I met Raphael, that was, I think, before this, long time ago, before this sanitary crisis. We met, and 3-4 months ago, and we, by looking at watching this movie and the presentation, there was really something to do. And I was particularly interested about the outcome of this test, and having these sensors not only for the short term, but also for longer term, and it's still low carbon concrete. It's still a long term development to know more about these new materials, and there was an opportunity, a window of opportunity of 1 week, and Converge managed to send someone with the sensors on time during the test. The test was about slag. But also about fly ashes, and the outcome was more for R&D instead of pure construction sites. But then having access to this data was helpful. Let me say that this technology it's used for, so these sensors still exist, but having this as an IoT and collecting data from the iPhone with the platform was something very interesting, in particular in the perspective of the platform that we developed dedicated on concrete for construction sites.
Raphael, obviously a lot of it is confidential, but can you draw us a little picture of the early stage results from this test, and how you maybe modified your models to this new low carbon concrete?
Yeah, absolutely. And you know, I'll talk in general terms, but I think one of the most interesting conclusions, and something that makes sense given the science for some of these concretes, is that they're incredibly temperature sensitive. And what that means is, typically when you go ahead and select a low carbon concrete based on slag or fly ash, you're often having or being forced to make a decision between productivity and efficiency, especially if you're in kind of cold weather temperatures, in our part of Europe. And what I think we're able to demonstrate is that by using the maturity methods and the technology like concrete DNA, you can actually get the best of both worlds. You can select a low carbon concrete that's based on slag or fly ash, which is obviously a lot more sustainable. Yet you can still benefit from the productivity improvements that concrete DNA drives, which means that in effect what you're doing is ensuring that you're bending both the cost curve and the carbon curve. And that's probably the most interesting result, which is that by putting sensors in there, you're able to actually maintain the levels of productivity that you would have otherwise had with a higher cement content mix that would have been otherwise, worse for the environment. I mean, I think the other, the longer term points, and Bruno was touching on it, is also being able to actually measure performance of these types of elements when they're, being used and post construction. We are starting to add capabilities like strain or gauges or load cells onto the Converge Signal, which gets embedded in the concrete. And this is such a new field, and there's so many questions around how those concretes actually behave, that the volume of data that you could potentially gather would be fascinating, and obviously provide a major competitive edge for the group as well. So it's certainly an interesting area, and what's happening here is we're applying cutting-edge technology on the IoT side of things with cutting-edge technology in concrete science and concrete technology, which is quite unique.
We obviously see a connection between concrete and low carbon concrete and Converge. Bruno, let's get back to momentum. How do you see a potential collaboration with Converge with this platform?
Oh, okay. Momentum is still at the beginning, at the early stage of its development. But currently, we have launched the first part of this platform on site to monitor and to monitor and the pouring of the concrete, the ready mix concrete at this stage. And so by doing this we see very positive feedback from construction sites about digital tool, and I can say also as part of the COVID-19, it helps also to avoid any contact and any paper communication. So that's something very positive, but still I'm still in the acceleration phase of the Leonard program with a promising perspective. And by being part of Leonard program, we look at different opportunities, not just focusing on our current value proposition, but always looking forward and definitely giving much more information about the concrete itself. For example, the carbon footprint of the concrete is very important in the low carbon concrete transition. And having this, but having also the productivity improvement by using the sensors can be part of the long-term value added proposition of momentum. It's still, once again, at the early stage. We have a lot of things to develop as part of our roadmap, but at some point, we think that I think that there is something to do, and being part of Vinci, if Vinci is working with Leonard, is typically to look at opportunities like the Catalyst program, and Converge is a good one, and to see any opportunity to have a win-win relationship as part of our development.
Exactly, that's the Catalyst program. Thank you. Raphael, a few questions on how you work with groups. How do you usually deploy with a new company like ours with the client?
Yeah, absolutely. I mean, I think it really depends on the profile of projects, but generally all our products are incredibly simple to use, and that's always been the central theme in how we develop products. So actually, we've shipped sensors and onboarded clients over Zoom or video calls, especially recently. And if you look at the Converge Signal, it takes about 30 seconds to install. Unfortunately, I don't have one here, but you literally, push it against the rebar, use a cable tie to tie it onto that rebar, and then it stays there as the concrete gets poured on top of it. So the Converge Signal family of hardware comes in two configurations. You have Converge Signal and Converge Signal Live. When it comes to Converge Signal, you have to talk to it over your phone and download the data over Bluetooth. If you go for the Converge Signal Live option, you've also got a gateway that sits on the outside of the concrete, which transmits the data over cellular to the cloud in real time. We then also have two other hardware products, a mesh-based product for underground tunnels, so a solution that's specifically dedicated to prefabrication, so precast concrete, where the sensor is actually reusable. And that's really to allow for the different use cases that we might encounter. So we would typically, ship the hardware over, and then train a team either in person or remotely. I think in the case of Poland, Bruno mentioned this earlier, we had about a week to get this done, and Ollie, our concrete technologist, who's probably on this call, kindly jumped on a plane with a day or two's notice to be able to make it out there so that we could actually be present for the trials as well. So whether or not there's physical presence from Converge really depends on the profile of the project. And obviously these days with COVID-19, if anything, it's quite nice to see that it's not required. And then there's a lot of training material, and the product itself is self-serve. Anybody could pretty much install it on the site and get it up and running.
Thank you. I have a question about the business model. What is usually the business model of the concrete DNA product, a fee or a one-time fee? And to weigh in on that, I also have a question from the audience if it's possible to have an idea of the price of this solution.
Yeah, of course. So the model, essentially concrete DNA comes in three flavors. Concrete DNA Core, which is the simplest version of the product, and typically comes alongside the Converge Signal. And in that case, you're purchasing the sensors on a consumable basis, and that's it. Depending on which hardware configuration you go, signal or mesh, the sensors are going to range between 40 and 100 pounds each. And I mean, this will depend on market, geography, etc. But that's broadly the range. And the Converge Signal is really more expensive because there's just more tech in there, and the Converge Mesh product uses it's less smart sensor. Then when you move on to Concrete DNA Pro, and you're essentially enabling real-time data, the AI functionality, the BIM integration piece, that's when there's a subscription element to it. So it's essentially a consumable fee for the sensors. It's a SaaS subscription. And that SaaS subscription will range from £500 a month all the way up to a few thousand, depending on the size of the site. And then finally, you've got the Concrete DNA Enterprise tier, which is typically what clients will go to when they use us across several projects. And we have some form of enterprise agreements with the wider organization. It also tends to be coupled with features that are to do with analysis of the data at HQ level. We're not just looking at an individual site anymore, but actually understanding how different concretes are used across an organization, or integrating with tools like Momentum, for example, that Bruno mentioned earlier. So we would have an enterprise agreement in place where you might enable API access. You would get the platforms talking to each other, and I think the future that we're seeing for construction is that you have to build open interoperable platforms. And what you'll end up with is both internal to construction groups, well, like the Vinci Group, but others, internal applications like our own, but then also third-party applications, say like Autodesk's generative design tools. And eventually, you're going to have all these AIs talking to each other and orchestrating the way the job site works. And that's I guess where the Concrete DNA Enterprise tier really comes in, because it typically involves more custom stuff with larger clients.
Yeah, data is of course a key aspect for corporation and for you. How do you ensure it's safe with Converge?
Yeah, of course. I mean, we've got the highest levels of security when it comes to the way we safeguard the data itself. I mean, clearly this project in Poland, for example, was highly sensitive, which has meant we've had to take kind of incredible care when it comes to storing that data and ensuring that we also comply with GDPR when it comes to personal data. So there's a lot of safeguards in place, and we're essentially applying the best-in-class encryption end-to-end on the software and platform side of things to make sure that that's all safe. I think you have to start building a bit of a framework to think about data. You've got the physical data, the data from the sensor. You've then got the construction data. So typically, actually, the construction data is the highest and most sensitive type of data that our clients own. Construction data might include the calibration of the mix. It might include the constituents of the mix when it comes to concrete, but it could also be the BIM model or the schedule. And, Converge has been involved in Ministry of Defense projects in the UK, for example, or nuclear power plants. So we definitely kind of got the safeguards in place for that.
And in addition to this, let me add that for VINCI construction, data confidentiality and security is very important, obviously, but it's also about data ownership. And on this specific test, we had a conversation with Raphael about this, and I was happy to see that we find an agreement. But it's very critical for VINCI construction to keep control and ownership of its data.
Yeah, I mean, I think, you know, to the difficult dilemma all the time, and one that I think is unresolved at this stage, but and we kind of acknowledge that need, and then the fact that all this data is incredibly confidential. At the same time, to be able to drive more value, what Converge has a hugely beneficial position in that we get access to high kind of volumes of data across the industry. Now, we would never disclose, and we segregate data when it comes to different clients, and that's the most important thing, because you'll have highly sensitive data. But then we will also benefit from the volume of data in the aggregate to be able to kind of drive value. I think this is that balance between the needs of a larger corporate to protect its data, and then the value that larger corporates can derive from startups when it comes to collecting that data.
Fully agree.
Bruno, you told us about your roadmap with Momentum, which is huge. What are your next steps, objectives with low carbon concrete in the coming month?
Low carbon concrete, there is definitely an opportunity to use more low carbon concrete, and it's all about the clarity, the legibility of this low carbon concrete. Some construction sites, they don't even know that they use low carbon concrete. Most of the concrete in the foundations today are already low carbon, using slag or fly ashes, and there is definitely an opportunity to push more low carbon concrete, and that's what I'm working on at the moment.
And Raphael, a bit of the same questions. You are deploying new functionalities, new products. What are the main announcements you can make in the coming month?
Yeah, so you mean in regards to low carbon concrete, or in regards to our product line?
To your product line.
Yeah, of course. So I mean, it really kind of comes back to those sensors I mentioned earlier and those different products. So we're actually in the process over the next few months of launching the first version of GeoDNA, which will support not just compressive strength monitoring, which is what we do today, but also tilt and kind of sensors and strain gauges. And that will open up a whole set of new applications in regards to the performance of the asset, both during construction, when it comes to optimizing the construction sequencing or the temporary works design, but also post-construction by looking at performance in at least the kind of the few years after that building's been built for now. And then shortly after that, and later this year, we're expecting offsite DNA to go live probably in the last quarter of the year, where we're going to start looking at the logistics process and the location of different assets in prefabrication. And I think that's actually really interesting, because there's a tie-up with low carbon concretes. We're using, and this is where you start seeing the synergies, concrete DNA in precast factories coupled with offsite DNA to track those assets, to actually start to optimize the embodied carbon, both in regards to mix selection for precast elements, but also the logistics of the delivery of those elements. And then when you bring on another layer to this, and you say, well, actually, I then want to look at the performance of those elements, and so you add GeoDNA into the mix, and that's when you look at the loads that go through that structure, after it's been built. So all that's actually happening this year on our side, and then finally the crane piece, which is probably going to be end of the year, beginning of next year, where we then look at those particular elements as they go through the crane, and that gives you that full life cycle. We're lucky enough to kind of raised a lot of capital right before this wider kind of pandemic happened, which has meant that we're in a really good place to actually really focus on R&D and start delivering these new products. And so what we hope to get to by the end of this year or beginning of next year is this stage where there's initial MVPs of these products, so we can actually start to prove the synergistic value. When you start making them work together, what happens? And that's what I'm personally really excited about. And then obviously the step after that is, okay, well, what happens when you start to connect that into other systems that within Vinci, for example, and start feeding that data into your systems and augmenting that data with construction data, and that's when the stuff you could do becomes endless.
I will wait for a few minutes to see if there are other questions from the audience. Let me first say that if someone wants more info or to get in touch with Converge, with Raphael or with Bruno, they will leave their email in the chat section at the end of the exchange. You can also go to the expo side of this platform, where every startups from the Catalyst program has a virtual booth where there is a video and a contact, so that you can do just after. And yes, if you want Raphael and Bruno, you can leave now your emails in the main chat. And while you do that, I think we have been really complete because I don't see any more questions besides the one we had before. Thank you, guys. We are. Okay, last chance. Well, I think we were really clear, and so we'll conclude for today's session. Thank you all for joining. The next panel will take place tomorrow at the same time and will feature SIF Drone. They develop fast, smart, and reliable marking solutions on unmanned vehicles, drones, and rover. And that will be for tomorrow at 5. Thank you, Raphael. Thank you, Bruno, and have a good day or have a good night.
Thank you, Louis. Good day.
Thank you, Louis. Thank you, Bruno, and thank you all for joining us.